You're listening to Electrician Live with your host, Paul Abernathy. Well, hey everybody, welcome to another episode of Electrician Live. In tonight's episode, we're going to do a little bit of exam prep. Now, I'm going to give you 6 questions, and again, they could be based on the National Electrical Code. They could be knowledge-based questions that are just talking about things that you should know as an electrician. And so it could be very broad. And what we're going to do is we're going to start a new series where we do these really short videos that are very precise when it comes down to asking you code questions and giving you time to be able to answer those code questions. So I will pause between each question. You should pause the program and look up these questions and then come back and answer it and see if your answers are right. That way it prepares you for taking your National Electrical Code exam. Now, if you already have a license and this is just being used to help brush up your skills, make you a better electrician in the long run, all of these questions are based on our Fast Tracks program for the 2020 edition of the National Electrical Code. So again, it's just good refresher information to help you hone those skills as the top-notch electrical professional that you are. Okay, so without further ado, let's get into the questions. Now, the first question is really a knowledge-based question. This is something that you should know as an electrician. And again, terminologies being what they are, this question should be one of those that if you get it on an exam, you buy yourself some time. Now, what I've told people many times is the process of taking an exam is doing it in waves. When you sit for your exam, you want to answer the questions that you know right off the top of your head right away and move on. Because what you do is you're building yourself a bank of time to use when you come on those harder questions and you need a little more time. So the first wave through an exam, you simply go through, mark the ones that you just know, and you're going to know a certain number of them just from your experience, your hands-on training, your prep work in the National Electrical Code. All of that's going to be a given, and you're going to be able to answer that question. If you get to any question that you stutter or it takes you more than about 30 to 45 seconds to even a minute, and you're just not sure, then you need to mark it electronically in that software when you're taking the test. And mark it, and you will get it on the second wave. Okay? But don't spend too much time on it. Don't get bogged down to it. That's the biggest mistake people make, is they get so locked into a question that they end up eating all their time up. You're going to have time. Just, again, there's a key and there's a method to the madness. So go through the first wave and answer what you know. Things that are just, there's going to be certain questions that you just know the answer to. Okay? And this should be one of them. So let's look at this question, and then you can pause and you can answer the question. Number 1, it says, which statements about the inspection of electrical work is or are correct? Number 1, it says, inspectors shall make as many inspections as necessary to ensure compliance with applicable laws. Item 2 says, an inspector shall issue a certificate of compliance when the completed electrical installation complies with all applicable laws and with the terms of the permit. So, both of these are either number 1 is correct or number 2 is correct. Either both are correct or neither one of this information provided here in this question is correct. So what's your answer? Number 1 or A, B, C, or D? Go ahead, take some time and answer right now. Come back when you're ready. All right. You took a pause. You looked the question over. Remember, this is a knowledge-based type of question. And if I get a bunch of these on an exam, you should know the answer by now. And that is, inspectors will make multiple trips to a job site until you actually pass. Now, it might cost additional money to make multiple trips, but they will come until the actual project is finished, okay? Until they are sure that you are in compliance with all applicable laws and rules. The next one says the inspector shall issue a certificate of compliance when the completed electrical installation complies with all applicable laws and with the terms of the permit. Absolutely. Whatever you do that's basically listed on the permit, they want to make sure that's what you're doing, so it's within the scope of your work. When it's done, they will give you a satisfactory completed green tag, a certificate of compliance, whatever they want to call it, stating you are completed. And when it's done, you might be waiting on other trades to finish, or you might be waiting to get the CO if it still has some other work to be done. But as far as electricians concerned, we have to look at it is that inspector is going to come back and make multiple inspections until it's completed. Once it is completed, are they going to issue a certificate of compliance or that green tag that says, okay, everything looks good, time to move on? What do you think the answer is? Okay, well, this is a knowledge-based question, and you should realize that both of these are correct. So it would be both 1 and 2. Both of these are very much applicable. So we'll check that, and we'll check our work. And that is correct. We'll go on to the next question. All right, now, in dwelling units, ground fault circuit interrupters protection is required in all the following locations except. Now, take some time, use your code book, and see if you can find the answer. Now, if this is one of those questions where you just know the answer right out the gate, then you're ahead of the curve. You can answer this and move right on, and you just bought yourself a boatload of time that you can use on a more complicated question. But I'll give you a few seconds, and then we'll look this question up. All right, welcome back. So let's look this up. First of all, it says dwelling unit, and it has ground fault circuit interrupter protection. So we're looking for the requirements. So let's say you weren't familiar with the National Electrical Code. Let's say you're just starting green, because we have to always assume that if you knew the answer, you moved on. If you weren't sure, what are the roots of this? What are the triggers in this question? One, it's dwelling units, so you know that this is not other than dwelling. It is dwelling unit driven, and we're talking about GFCI protection. And it's all about the locations where I have to put GFCI protection in for these circuits, okay? So when looking at it, we're going to think, well, all of this seems to be driven towards GFCI requirements, and because it's location driven, where would I go to get this info? Well, there's a couple of things you could do. The first thing you could do is go to the National Electrical Code if you don't know, and you could go to GFCIs. Okay, so let's do that. So I'm going to grab my code book, and just like you, and let's say I didn't know, and I'm going to go to the back, and I'm going to get to G for GFCIs. And again, if you have your tabs, then your tabs can get you back to the index much quicker. So I'm back in the back of the book here. And again, I'm not expecting you to see my screen. I just want you to be following along in your code book. So what you'll find is you'll have a ground fault circuit interrupter is listed here. Next thing you're going to go through and say, okay, if I go down it, you're going to go down and you'll see all the requirements down there. You keep looking down and you say, okay, you probably could get your answer from right here, be honest with you, because you see that you move down, you see one that says bathtubs, hydro massage. Okay, again, not really in the question. You keep on down and you see, well, bathrooms and dwelling units. Okay, bathrooms was mentioned. You also go down and you see outdoors. That was mentioned. You also see, if you move it down, you see garages for dwelling units. That was mentioned. And what you'll notice is all of them are at 210.8. So that tells me if I'm preparing for an exam that I'm going to do what's called scanning at 210.8. Now let me explain this real quick. I guess it's best to come back and explain another technique. Look, the National Electrical Code, the index, is not the Holy Grail. You're not going to be able to just sit for an exam and not have some sort of practice, some sort of understanding common terminologies in order to be able to just ace that exam. You need to know some of the terminologies when you're preparing for an exam. Now, the index can help you. It's same as the table of contents can help you. But it doesn't take the place for some general knowledge, and that's why you have to use a structured plan. Now, not all plans are perfect. Some people like books and DVDs. Some people don't like to read. Some people like to listen to MP3s. Okay, well, our Fast Track program gives you the best of all those worlds. It might not be perfect for you. but it does provide you with all the necessary information in the code in order to help you pass an exam, or just to learn the National Electrical Code a little bit better. But you can do it if you just get a structured plan, whoever you use to do so. Now, in this case, there's enough information that puts me into 210.8. And as you move through a structured plan and start learning the code, you're going to learn that 210.8 is talking about ground fault circuit interrupters when dealing with branch circuits. That's kind of what we're talking about here. So we're going to go to 210.8 of the National Electrical Code. And let's see, I'm going to do this. And if you had a tab, it would put you right there. But I'm at 210.8 of the National Electrical Code. This is ground fault circuit interrupter for protection for personnel. And then you'll have an A and a B. And of course, you'll have a C, a D, an E, an F, or whatnot. So based on this question, it was talking very much about like locations, and it was very much dwelling unit was in there. So dwelling units. So that's what A is. So you get here, and what are you looking for? Those triggers from the question. You saw the term outdoor. You remember that. You saw the term bathroom. You saw the term garage, and you remember bedroom. Now, common sense might kick in at this point. You might say, well, you know what? I've never really seen a GFCI in the bedroom. I've seen them in garages. I've seen them in outdoors. Okay, I've seen them in bathrooms, never in the bedroom. So again, this could be a question, you answered it and you moved right on. That's the whole point of this lesson. If you see it, you know it, you answer it, you move on, you bought yourself some valuable time. If you're new to this and you didn't know, then you see where you went to ground fault circuit interrupter in the back of the code. It drew me to the requirements because everything back there in 210.8 had to do with dwellings. That's a trigger. That's what we're looking for. So that got me here. Now, I look at the dwelling units and I look down the list and I see that bathrooms is A1, garages is A2. So we got two of those kicked out. A3 is outdoors. So the only one left is bedroom. If you look down really quickly, you'll notice that bedroom is not listed. So what are we going to do? Well, we'll go back to the question. And in this question, since all of these were listed except for bedrooms, we're going to say bedrooms. And we got it correct. All right. Next question. It says, what is the minimum number of 120 volt, 15 ampere, 2-wire lighting branch circuits required for a residence that is 65 by 35 feet? Now think about this. They're asking a question and they want to know how many lighting circuits are necessary. And they're giving me a dimension. So when they give me a dimension of the building, I know that they're asking me for a dwelling unit application because it says a residence. And if you study in a program, you're going to learn that when you ask a question like this, they're basically saying to you, hey, I know that you're going to have to do some type of calculation, and this is going to fall under the calculating rules. Okay, so what do we have to do? Now, there's two ways that I like to approach this. The first way that I like to, oh, wait a minute. Wait. I've got to give you time to answer this question. So take your time, pause the episode, and answer the question. All right, welcome back. Did you get the answer? Well, we'll see. We know you got some answer, so we'll see if it's the right answer. So what's the first thing that I would do in this case? Well, the first thing that I would do is determine what is the actual VA or watts, which in this case will be utilized synonymously for this application. What is the value that I'm going to use to determine what the number of circuits I need? And I have to get a value first, okay? So the first value I'm going to get is I'm going to go 120 times 15 amperes. That's going to tell me what the actual VA or wattage, more accurately, power that can be consumed by this circuit. And of course, I'm going to utilize that as VA in my calculation. So in this case, I'm going to do 120 times 15. And that gives me 1800 VA. Okay. Now, if you want to say watts at this point, that's fine. It's not a big deal, but you're going to have to utilize it as VA here shortly. All right. So don't get overly deep into this right now on the exam. Just follow the steps. All right. So that's 1800. Just remember that. Now, what's next? Well, I need to know what the general lighting is at this point because it's asking me basically a general lighting question. Now, when I'm thinking of general lighting, where would I go? Well, it's a calculation. Remember, it's giving me dimensions. So I have to do some type of calculation. Well, if I was doing this, then I know immediately that's going to take me to 220. And since this is asking me about branch circuits, I'm going to be in part 2 of 220. Why? Because we will learn that part 3 is dealing with the standard loads calculation for service and feeders. And part 4 is an optional method, and part 5 is for farms. So if I'm doing any type of branch circuit calculation information, then I'm going to stick and start off in a part 2 location so I can get my foundation down. So let's go on and start that, and let's go at least to 220. Okay. Now, if you're saying, well, Paul, how did I get there? What is it asking me? It's asking me for a load calculation. So it wants to know what is going to be the actual minimum of a certain number of circuits based on a calculation. Okay. So I might go to the back of the book and I might go to loads. I might even go to calculations and it might send me to loads. But that's would be a trigger for me. Now, one of the other triggers, and I'll do it, is I might go, if I was doing this, I might go to branch circuits. So let's do that. And you follow along with me. And we'll just assume we didn't know. And we'll go and look and see if there's anything under branch circuits. See, the point of educational training is for you to be able to look at the question and either utilize the knowledge that you have based on your experience, or to be able to dissect information out of that question that can help you answer that question. Now, the index is not the holy grail, but it can help you at least get you in a starting point, because there's two different things that we look for. We either go based on knowledge, or we get something that directly sends us there from the index, or we do something that gets us close and we use a technique called bolding and scanning. And that is where we hit all the bolds and then we look for triggers that match what the question was giving us. And that's how we will bold scan it. Okay. So anyway, let's go to branch circuits. And here's branch circuits right here. You have your code book. Don't rely on mine. It's a little blurry. Not the best camera in the world. We have new ones coming. But anyway, and you'll know the difference when you see it. So branch circuits, and I'm going down here, you'll see calculations. It says calculations of load, 220, part 2, okay? All right, so gives us some starting points. So we're gonna go to that. Now I will, while I'm here, I always tell students, while you're there, and you got there pretty quickly, just look a quick again through there and see if there's anything that was even more direct than that. And just kind of give it a look through so that you can jot that down. Because here's another tip. When you're in that index and you're looking for something, don't be afraid to use that scratch paper. Don't be afraid to use that dry erase board that they might give you. If you see something and you know that it's 210, write down 210, part 2, but then scan it real quick. And if you see anything else that's there or anything else that may be in 220, excuse me, I said 210, 220, part 2, make sure that you jot it down so that you don't have to keep flipping back and forth, right? Save you a little time. So again, it's all about time management on an exam. Okay, so we want to go to 220 part 2. I have no idea why I said 210. 220 part 2. All right, so I'm going to go to 220. If you have a tab, it'll take you right there. So I'm going to go to 220 part 2. All right, now 220 part 2 covers our general information. And that's when it starts telling us things like, how do you determine how many VA per square foot and other things like that, receptacles and things like. So again, 220 is where we're going to start our calculation. So once we are here, next we're going to go to part 2, and this is when we do bolds, and we're going to look at the bolds. We're trying to solve a lighting requirement. So we go down and we see general. And it says 220.12, 220.14, 220.16, 220.12 is the general lighting, 220.14 is receptacle or other types of loads, and then 220.16, that is dealing with loads for additions to existing installation, okay? Not part of our question. So when I look at this, I'm saying, okay, well, it says to go to loads, and I need to do for dwellings. Okay, so other loads. So as I scope down this, and we're in the 2020 edition of the National Electrical Code, I see that we're talking 220.12 says lighting loads for non-dwellings. Well, this was a residence. This wasn't a non-dwelling. It was a residence. We know that's a dwelling. So I keep on going. And then we'll notice that I get down to 220.14. It says other loads, all occupancies. Okay, so then I scan down there because I'm looking for dwellings. That's what I'm trying to function with. And I keep on going and I notice, boom, 220.14J. And that says dwelling units. What does it say? It says in one family, two family, and multifamily dwellings, the minimum unit load shall be not less than 3 VA per square foot. All right, so it's asking me the lighting. I have to go with the fact that what is the lighting? What do I need for this application? It's 3 VA per square foot. How many square foot did I have? Okay, we've got to go back to the question. So let's go back to the question and get our trusty calculator out. Okay, remember, we already know it was 1800 VA or watts, however you want to do it. I like to convert it to VA so we can work this out. But that's for the circuit. So that's one 15 amp circuit has, well, 120 volt is 1800 VA. All right. Now, 65 by 35. Remember what it said? It's 3 VA per square foot. So I have to do 65 times 35. And that is 2,275 times 3, because it's 3 VA per square foot, equals 6,825 VA. Okay. Now, once I establish the VA, and this point now, it doesn't matter whether you want to call it watts or VA. It doesn't really matter at this stage. We use VA because it's going to help us as far as our overall calculation. So once we have the 6,825, now we're going to divide that by the 1,800 because that's what one circuit was. And we're trying to find out how many of those we need. So I divide that by 1,800, and that is 3.79. Well, you can't have 0.79 of a circuit. So you round it up to 4. So this is how I would determine how many circuits I need for the general lighting in this application, if this is what's given to me in this question. So let's go answer the question and see if we're right. So I need 4. That is absolutely correct. Okay. Now remember, it said residence. You have to have some knowledge here, because that's not going to be in the code. A residence is a dwelling unit. Okay. So you have to have that kind of knowledge. When I see a 65 by 35, that's telling me I have to do a calculation. And what I don't want you to do is go 65 by 35 and then try to divide that by 1,800 and then ends up 1 point whatever, and you think 2 is the answer. No, that is not going to be the accurate answer for this. Okay. Because we have to know that we're going to have to apply something to this in order to come up with a value. All right. So that's how you come up with that answer. Okay. Just remember, you see something that's requiring you to do 65 feet by 35 feet, sizing the dwelling or the residency, which is also the dwelling unit. Remember to go to 220. It's a calculation. Follow the rules there. If it's a dwelling unit, which is what a residence is, then you follow the rules here, and it's telling you 3 VA per square foot. Okay. How many square foot was it? 65 by 35 foot times 3 VA. That's why I like you to convert to VA, even if you're doing the 120 times 15 to get you 1,800. Utilize that as VA so that you can just keep everything together nice and tight as you're moving through this. Okay. Just remember though, when you get over into doing other calculations in 220, dryers, for example, or watts is synonymous with VA as well. So same thing for ranges and ovens and things like that. So again, not new information here, but just kind of things to build on and think about. Okay, let's go to the next question. All right, the next question is, an individual 20 amp rated branch circuit serving a single receptacle, okay, simplex, single receptacle. The rating of the receptacle must not be less than A, 12 amperes, B, 15 amperes, C, 16 amperes, D, 20 amperes. Now remember, we're talking about the 20 amp branch circuit serving the receptacle. We're looking for the rating of the receptacle. Okay, the receptacle. We already know it's a 20 amp branch circuit. We're looking for the rating of the receptacle. Okay, now I'll let you work this out. Take a couple seconds, look it up in the code, and then we'll come back and look it up. All right. Hopefully you had a good time looking it up and you were able to look this answer up. Remember, pause when I say that, open up your code book, look up the answers, and then come back and we will look at how we would find this question. All right, so in this question right here, we have to dissect a couple things. We're talking about branch circuits and we're talking about receptacle ratings. Those are the core things. Now, something else that's going to play an important part here is the term individual, okay? An individual 20 amp rated branch circuit, okay? That's important because you have definitions of branch circuits. You have general purpose, you have small appliance, you have individual branch circuits, okay? All those type of terminologies that are found in Article 100 of the National Electrical Code, it's going to serve you well. Hopefully you take a lot of time learning definitions. It's critical that you understand definitions so that you can mix that up with your knowledge that you've gained working with your tools and preparing yourself to take an exam, okay? So we know that it's an individual branch circuit. We're talking about a receptacle rating, and we need to know what the rating of the receptacle must not be less than to be on this individual 20 amp branch circuit. So let's look it up. Where would we go? Well, let's say we went to branch circuit. We were just there. So let's go to the index. If you didn't know, now if you knew this, you check it, you answer it, you move on. Okay? Now, a little tip here. A 20 amp rated branch circuit is rated 20 amps. Now, if it's a cord and plug or it's some other application like that, things are going to change. But right now, we just want to know what a receptacle rating is. We're not asking about what the ampacity that I can have on this circuit. We're not asking what I can exceed. We're simply asking what is the rating of the receptacle, and it must not be less than what to be on this 20 amp individual branch circuit. A lot of information there. Okay, so let's go to the code, and I will do it as if we don't know the answer. If you knew the answer, mark it and move on. But if not, let's go to the code, and I'm going to start my journey in one of the key charging statements that I saw, or I guess I should say the triggers, is branch circuit. So I'm going to go to branch circuit and start my mission there. So I have branch circuit. Now, when I'm in branch circuit, I'm looking for anything, and we see the word individual. So if I'm looking down this list and seeing what's relevant, I got my little notepad here. I'm going to actually mark any of them that I see so that I can make one mission back here, and that's it. Save me time. I'm noticing that I'm seeing a lot of things. I'm seeing that general purpose that we talked about. I noticed that you'll see, if you keep looking, you'll see small appliance. That's branch circuits we talked about. Notice you'll see individual. Okay, we're talking about an individual branch circuit. When you see the index and it's offset, when it's farthest to the left, you see like right here, you can't see it right here. Everything that's offset below it is associated with that term. So in this case, individual has an offset, and it's talking about definition, overcurrent protection, permissible loads, rating or settings, and requirements. Okay, so we have a lot of information there. We're trying to find out for the receptacle. Okay, so that might be something that we write down. We might look at the best option here and say, okay, ratings or settings. Well, that looks like that's in 430. If you learn, you'll notice that that happens to be rating and settings. That's motors, okay? So not really what we're looking for. So I'm looking down this list and I go, okay, permissible loads, okay, 210.22. We do know that branch circuits are in 210, so we know we got to start somewhere in 210, okay? Now, you're saying, yeah, but Paul, I don't know that. Well, you kind of do, because if you're studying right, you're going to start learning the different articles, and you're going to know that 430 is motors, and that has nothing to do with what we're asking. We're talking about a branch circuit, so we're in 210. So again, I can't make the index be the holy grail, but you can utilize it, and at least it gets you to a starting point, okay? So in this case, I'm looking down, I'm thinking, okay, well, 210.22, since I know it's 210, just write .22 down, and put 210, and everything that goes under it, you know that you're already there. You can look at them as quickly as possible. Now, you're going to use bold scanning, okay, unless it gives you something directly, but this is how you start. And so, and again, it works out on an exam. You get really good at this. And remember, Remember why we're buying ourselves that extra time? Because we need to do that to be able to navigate through the code if there's something I don't know. Now remember, let me give you a little secret here. You are never going to pass the exam if you have to look up every question on the exam. You don't have enough time. It means you were not prepared. You did not have a structured plan, and you went into this and you just did not give the dedication that it needs. This is not just about passing an exam. This is about learning the code so that you can do accurate, safe installations in your career once you get that license. So again, the license is just a benchmark that you have to hurdle over. Once you do that, the National Electrical Code is a never-ending learning experience. Okay, enough of that. So I'm going to go down this list again, and I keep on going down to see what else might be relevant. And then I get over to, again, ratings, and that is 210, and notice that it's part 2. So I'm going to jot down part 2. And I'm going to continue down, and I'm going to see anything else that I think is relevant. Okay, now, so for me, I'm going to go to 210, and I'm going to go to part 2. And I'm going to see if that's going to feed me the information that I need. Okay, so let's come back to the question, and I'm going to go, and again, I got that point 22 as well. Okay, so just so you know. All right, so I'm going to come back, and I'm going to go to, and I've got my code book too. And I'm going to go to 210, and I'm going to go to part 2 because I feel pretty confident in where we're starting from. All right, so part 2, and that is branch circuit ratings. Okay, now what is the question? The question is about the rating of a receptacle. So this is where bold scanning comes in. I start looking at the bold headers and the ratings, and I'm looking. Now in this case, I also noticed something. I've got answers that are giving me something in amps. So the amps has to be something that's actually in here, right? So what I'm doing is I'm going to scan quickly and look at the bolds. So I'm going to 210.18, 210.19 is dealing with conductors, doesn't help me. I'm moving past conductors. Next I go to 210.20, that's overcurrent protection. I'm going to 210.21, and 210.21 says other outlet devices. Okay. That's what we're kind of talking about, devices. And then it comes down and it says lamp holders, and then the second one says receptacles. I'm talking about a receptacle, so I'm at the right place. Then it says single receptacles on an individual branch circuit right away. Trigger. My answer is going to be here, or it's going to tell me where to go. And it says a single receptacle installed on an individual branch circuit shall have an ampere rating not less than the rating of the branch circuit. What's my branch circuit? 20 amps. So what's the rating? 20 amps. Remember, the question wasn't about cord and plug connected equipment or anything like that. It is talking about an individual single receptacle on an individual branch circuit. And we just found the answer. So we're going to go to the code, or excuse me, go back to the question. We're going to answer D. And I will check my work. And the answer correct is D, 20 amperes. So you kind of see how we worked through it and dissected that question. Pretty basic question, but we had to kind of work through it, kind of see where it would lead us, okay? And branch circuits led us there. Pretty simple. Now, could I have gone to receptacles? I don't know. Let's do it, because that's all how you learn. You learn by taking your exam time, your practice time, like we're doing here, and you literally cross-reference answers to see what would have given you. And by doing this, you start to learn the National Electrical Code, okay? That's part of the process. All right, so let's go to the back, and I'll go to receptacles and see if that said anything about single receptacles and ratings. So that might have been what I did. So I'm going to go to the back and see if we have anything receptacles. Okay, I see receptacles, and I'm going to follow down it. And we all got to remember something. There is an actual article on receptacles, and you'll find out pretty quickly that that is 406. So you got to be careful. You're in receptacles, but you just need to be careful how you read, because if you do that and you go to 406, it's not really going to help you. So I'm looking down here and seeing anything that would have something directly related, and to see where it might say receptacles, and just to see. And you see maximum cord and plug connected load. Doesn't help much. Okay. Not going to help me anyway. And now it might have got you into 10.20. It might get you in the area. Okay. But again, not really something that's going to stand out to me right away. So I'm going to keep on looking. And then receptacles. And then you'll notice it says ratings for various sizes. And that's going to take me to 210.21. Now, is it exactly 100% taking you to 210.21a? Probably not. But it does take you, to 210.21b. No, but it takes you to B3, but it takes you in the area. And sometimes that's the best that the index is going to do. It's getting you somewhere close, and then you switch into those bold scanning techniques where you're looking for key terms that are in your question and maybe even in the answer so that you can get there quickly. Okay? So in this case, we knew where to go, and that sent us to 210.21b. In this case, B3, but that's okay. We want to get there. So that's another way to do it. You could have used receptacles to do that. So there's many ways to do it using the index, or you might have already known this question and you didn't need to do it and you just bought yourself a heck of a good amount of time, right? All right, let's go to the next question. All right, the next question is, the grounded conductor of a branch circuit shall be identified by an outer covering color of any of the following except. Now, A, blue with 3 white stripes. B, yellow with green stripes. C, white. Or D, gray. Great example of a question. If you know the answer, you mark it and you get your butt off that question, you just bought yourself a boatload of time. That's how we do it. That's your waves of now, if I didn't know this and I spent more than 35, 45, more than a minute or right about a minute, then I'm going to mark this on my exam system and I'm going on to the next question. Okay. Save this for the second pass. Okay. Where you can spend a little more time on it. In other words, build yourself a bank of time to be able to utilize it. Every question is worth a certain amount of time. So you want to generate a bank of time. Now, in this question, where would you go? Where's the trigger here? What are we asking about? We're asking about the grounded conductor and how we would identify it. That's the root of this question. So if you didn't know what article deals with grounded conductors, then you would go to the index. Of course, you could go to the table of contents for this one as well. But we'll go to the index, okay? So let's kind of look it up and see. So in my case, I am going to go to grounded conductor in the index, okay? So I'm going to get my code book. You should be doing this as well. Now, take your time, pause this if you need to, look up the answer, and then come back and give your answer. But I'm going to look, and it probably sucks because I already told you where to go, and I probably shouldn't have done that. But that's okay. We're learning. I'm learning. This is a new segment we're doing. Tell me if you like it. Thumbs up. Share it with everybody. So, grounded conductors is a term that's in the index. Now, we're looking about what? We're talking about identification of a grounded conductor. So, I look down this list and see, well, I'm going to look at everything here quickly and see what is germane to the question that I'm dealing with. Now, since this question said grounded conductor, and then it's giving things like white and gray, the savvy code person will realize that we're also talking about a neutral conductor. Now, not always the case. You don't always have a neutral, but you typically have a grounded conductor. But in this case, since they're giving these references, chances are you're going to have a neutral. But I want to look here at the grounded conductor first, because there is a definition of neutral. I think we're going to be okay in the grounded conductor because that's what was given to us in the question. So, look down the list and immediately I see grounded conductor identification. 200.6, 200.7 is, and then 210.5a. Now, at this point, you could write all of these down. But what you're going to remember based on your studies is that 210 is dealing with branch circuit. The question was specific to the grounded conductor. Article 200 is dealing with the grounded conductor. And you know this because you practiced. You've worked on this. You've been moving through the index. That's what I mean by as you get better, you'll notice how things flow. Okay? So in our case, we're going to go to, we don't really care if it's .6 or .7 at this point. They're right there beside each other. So we're going to go to 200.6 and we're going to start our journey from there. Okay? So let's go to 200.6. You have a tab, you go right to it. If you already were savvy in the code, then you already knew that Article 200, which is very short, by the way, it's only like 2 pages. Then you would have gone there right away and you would have used what we call bold scanning. You would have looked at the bolds and you're looking for color identifications because that is what was given to us in the question. And we're talking about identification. So we're looking for terms like identification. We're looking for terms like the colors, white, gray, things like that, in order to be able to tell us we're at the right location. So when I go to 200 and I use bold scanning, I look at it and we wanted to be at 200.6 and it says means of identifying the grounded conductor. It's kind of what our question was. So if I look at it, what does it say? All right. So in this case, it says size 6 and smaller. And of course, you also have size 4 and larger. But something is pretty consistent with either one. It relates to this question because we only can use the examples that are in the question. It says, let's just assume 200.6a right now. It says, the insulated conductor shall have a continuous white outer finish, so white. It says the insulated conductor, and again, we're talking about identifying the grounded conductor. The insulated conductor shall have a continuous gray outer finish. Okay, got that covered. The third option says the insulated conductor shall have 3 continuous white or gray stripes along the conductor's entire length on other than green insulation. So I've got some other options here, but the key thing here is going to match all of our key points to this question. So again, we got to go back to the question. So in the question, can white be used? Yes. Can gray be used? Absolutely. Can blue with 3 white stripes be used? Absolutely. It said that in 200.6a3. How about that yellow? Now, yellow could be used, but it says it has to have 3 white or gray stripes, not green stripes. Okay, so the problem here is the stripes or the stripe. Okay, so the answer would be A, C, and D are very much yes, you can use. B, you cannot. So your answer should have been B. Again, if you answered this without needing any time, you did good. There you go. And let's do the last one. Now, the last one. Now, this can be tricky for some people, but you got to read the question. The rating of a branch circuit overcurrent device supplying a low voltage wiring system in 15 amperes. Okay. It started out with that saying it was a branch circuit overcurrent device supplying low voltage wiring system is 15 amperes. Remember, 15 amperes is low voltage. Don't confuse that with things like low voltage, which is not defined as such, for things that are like doorbells, 12 volts, 24 volts, things like that. That's low voltage too. But 120 volts is low voltage, in case you didn't know that. All right, so you don't start getting medium voltage until you get to 2001 up to 35,000 volts. So yes, 2,000 volts, that's low voltage, believe it or not. Okay, so in this question, let's get to the root of the question because that was just a statement. The question is, what is the minimum allowable size equipment grounding conductor required for this dedicated circuit? Okay, couple ways to find the answer to this. Okay, so let's kind of think about this. So we have equipment grounding conductor. That's what it's asking about based on the overcurrent protected device. So there's kind of some ways to do this. If you're savvy in the code, your question might be, well, what is the smallest conductor I can have, period, in the code? Okay, well, if you did that, we're talking about conductors. So if you think about conductors, then you might go to Article 310, dealing with conductors. That might be the way you might want to try to tackle this. The other way you might dissect this is, look, you're asking me about an overcurrent device, and you're telling me what is the size equipment grounding conductor I need for this circuit, and this circuit is protected by 15 ampere. So that would put me either in, I'm not going to give you the answer yet. I'm going to give you an opportunity to answer this question yourself. But I am going to show you two trains of thought. So go ahead and answer the question. Okay, hopefully you answered it right. Let's see where we go with this. So if you were to want to know the equipment grounding conductors, one thing somebody might do is they might go, and we're going to look at this from a couple different angles since it is our last one, is they might go to equipment grounding conductors. And if you go to equipment grounding conductors and you look down and you follow down the list, and we're just kind of looking, and hopefully you are following along as well. And we're looking down it, and we're looking for anything that would be relevant to our question. Sizing. We are sizing. We need to know the size of the equipment grounding conductor. So I noticed that 250.122 is dealing with sizing. Now, I've got some other references here. If you don't know, you wouldn't know not to exclude them, right? So I'm going to write 250.122 down, but I'm also going to jot down the other references as well, so that if the first one doesn't pan out, I don't have to go jumping back here in the index again, okay? So I'm going to write 250.122. Of course, I might write 250.190 as well, but it might not pan out, but I'm going to write it down. So then I'm going to go down and set sizing, and I'm going to see if there's anything else that would help me. Okay, so in this reference, I got 250.122. Now, in an exam, that's where I'd go right away. And let's do that, 250.122. So again, I'm looking for the equipment grounding conductor, so I'll go to 250.122. Hopefully you got a tab for that. Most common tabs do if you tab your book. I don't necessarily think you have to tab your book, but if you do, there you go. It's going to get there a lot easier. So now, what does it say here? It says 250.122, size of the equipment grounding conductor, general. It says copper, aluminum, or copper-clad aluminum equipment grounding conductors of the wire type shall not be smaller than shown in table 250.122. Okay, in 250.122, you'll notice for the 15 ampere, it says 14 gauge copper or 12 gauge aluminum. Well, 12 gauge aluminum is not the option here, but 14 gauge copper is the option here. Notice it says a 14 gauge aluminum. Don't make the mistake and accidentally click it going so fast that you make the mistake. I would hate for you to fail your exam by one question because you just got too ahead of yourself. And maybe this is what happens when you go click, 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 click. You need to make sure you know the answer. That's just without a doubt know it before you move on. What I'm saying about the wave process is that when you see something and you look at it and you just know the answer, commit to it and answer it. If I'm looking at this and I'm like, I'm looking, and it's coming up on a minute and I don't have the answer, well, you had to look it up anyway. But once you get to about a minute, that's it. You're going to start killing the clock. Mark that. And most computer systems that you take exams today allow you to tick check it so that you can come back to it later. Any of them that you're going to skip, you tick it and move on. Now, some people say don't skip it. At least answer something. Rule out the most obvious. You know they don't make 14 gauge aluminum, so rule that out. Okay? So, in this case, you know 14 is smaller than a 12 copper, and a 10 aluminum is larger than any of them. So at the end of the day, you could probably do deductive reasoning and find the answer to this question. But I want you to mark it on the system if you don't know the answer in a minute, so that you can come back on the second wave and dedicate that time just to those questions that you needed more time on. Okay? So that's your second wave. And then on the third wave, you still go over 2 minutes on the second wave and you can't answer it. Keep it marked and go to the next one. You're still going to be answering them, but at that point in the second wave, you at least want to answer the question, even though you're marking it because you don't know exactly. At least mark it. And then keep it marked in the system and go to the next question. It might be right or it might be wrong. You're going to check it on the third wave. The problem is if you run out of time, we want to make sure that you leave no answers blank. You want to at least have a shot at the game, right? Nothing blank, okay? So in the first wave, just answer. If it takes you more than a minute, check it and move on. Don't even have to answer it. Just check it and move on. In the second wave, you want to spend at least 2 minutes on a question. If you still can't get it, make an educated guess, still leave it marked so you can come back and look at it again in the third wave and spend a little more time on it, okay? Now, if you find the answer in the second wave within 2 minutes, then uncheck it because you don't need to get it on the third wave and you don't want to get confused. Those systems have the ability for you to check on and check off these things, okay? All right, so that's how I do it in a multi-wave format. All right, so now in this question here, that would be our answer, 14 gauge copper. But let's say you're thinking, well, what is the smallest conductor anyway? I mean, 15 amp circuit is the smallest that I can have in a building, in a building as far as the overcurrent protected device. Now, so we do have fuses in 240.6a that get smaller. But when we're talking about branch circuit overcurrent devices, typically our experience would say in a house, it's really not going to be less than 15 amperes in a house for our branch circuits. So maybe I would say, okay, well, what size conductor would I need, or what's the minimum size conductor I need? So one thing you could do is you could, again, the first choice was to use the equipment grounded conductor. But I'd just like to give you other options in case you feel like you're struggling, is let's say I go to conductors. And I'm going into the back of the index, and we'll go to the index. And again, I'm going to look for conductors. And if I go to conductors right here, okay, in my code, okay, you can't see it, but hopefully you got your code book out doing it. You go down and you start seeing some applications, and I'm looking down it, and I'm going to go down and see if I see something to do with sizing and see what I might have, just to see if there's anything here. Again, this is a process. This is what I want you to do. I want you to take a question. I want you to dissect it, because what I'm really doing is, without you knowing, you think I'm just having you do this. No. What we're doing is having you manipulate through the code references, looking at the indexes over time during a study program. You will start to understand what's back here and what's not, and it'll become a lot quicker. You know, you do things repetitively, you get better at it, right? So I'm looking down, and I'm looking down here, and I'm seeing, now I do see equipment grounding, and it sends me to equipment grounding conductor. If I had gone here first, that's probably would have sent me there if I didn't know that equipment grounding conductor was actually in the index. Okay, hopefully you do know that, but if you didn't, and I go down and just keep going down and see it if I have anything that might be beneficial. See if there's any minimum sizing. Okay, so I've got some minimum sizing requirements, but again, not too much that would be any trigger for me. And I'm going to keep going down. And I see sizing. Well, I see sizing, and really much that has really nothing to do with what we're looking at. But you wouldn't know that unless you really knew. But I'm just kind of looking down and seeing anything that might be beneficial under sizing that would get you into conductors. Now, the only thing that would get me into conductors is, the fact of the matter is that conductors falls under what? 310. That's the kind of the scope of conductors. But I don't really see anything in here that would give me anything additionally that would drive me to that. So obviously, equipment grounded conductor is the way to go. The reason I say this is if you find yourself stumbling in 310, and we'll go look at it just so you can see it. So if you find yourself in 310, up at the very beginning of 310, you're going to see a lot of information. Okay, if I can get there. So this is conductors for general wiring. You'll notice that it says conductors in 310.3. You can't see, this is blurry. But what it says is minimum size of conductors. And it says the minimum size of conductors for voltage ratings up to and including 2000 volts shall be 14 gauge copper or 12 AWG aluminum or copper clad aluminum. So you know that the circuit itself can't be smaller than 14. Okay? All right? So at least you know that it would be 14. But the real way to get here on this one is to use the equipment grounding conductor because it gave you an overcurrent protected device. And all equipment grounding conductors are sized based on the overcurrent protective device. Okay? So we'll go back to the browser and end this up. And we will choose 14 gauge copper. Perfect. We got all of them correct. Okay? So, remember, take your time. Look at each question. And always read the question and make sure you understand what the question's asking you. That's key. Always make sure you understand what the question's asking you. And there's many ways to find an answer. Okay? So again, on my exam prep stuff, I want an exact code reference and I want the answer. In reality, when you're going through the code and you're doing bold scanning, you're hitting fine points and looking for those triggers that are in the question, things are going to stick out to you, and that's going to help you. Some people would like me to say that everything is in the index. It is not. If you have to look up every question in an exam, you are going to fail. You need to prepare. What better way to prepare than getting in a structured program like our Fast Tracks program? But there's other programs out there that can utilize the same concepts. Always take your question, always look it up, always dissect it. Whether you get it right or wrong, make sure you still look at all the possible terminologies in that question and how it might find the answer. That's structured training, because in some of those questions, we looked up multiple triggers and it would have given us the answer. That's the best way to do it when you're preparing for an exam. So hopefully you got something out of this series. Till next time, stay safe. God bless. You've been listening to Electrician Live with your host, Paul Abernathy.